In the 60s and 70s, two American jetliners dominated the world airliner market. They were the Boeing 707 and the Douglas DC-8. One, the iconic 707, even had a popular song written about it, which became an international hit. Both airliners used a similar modern swept-back wing and four-jet layout that was considered extremely advanced for passenger planes at that time. As this duo of American commercial successes did so well, it is often overlooked that a third U.S. company, Convair, had also entered the fray, and its airliner might have been the fastest of them all. One of the most common expectations for jet aircraft is that they are fast. Though jet airliners also fly smoother, higher, and are quieter than other passenger planes, their most powerful feature of all is that they are faster. So it is perhaps logical to assume that in the competitive world of airlines, the fastest jetliner would also be the best. And if you were the Convair Aircraft Company, which were equipping the U.S. Air Force with both fighters and bombers that could fly at twice the speed of sound, it is also a reasonable assumption that their jetliner offering would indeed be the fastest in the air. The 990 Coronado. She was the most beautiful airliner of her time, and certainly the fastest. Ron Strauss recalls the 990's phenomenal speed flying in and out of Berlin for modern air transport.
When we flew the corridor in Berlin during the Cold War at 10,000, the Russians controlled the airspace. So we had to be down before the boundary. Lots of times on descent, we'd get the 990 up to 0.912 Mach, which was really fast. In fact, it would get going so fast that we'd get a vibration in the fuselage, and lots of times it would suck the nose gear doors open, so we'd just put the gear handle in the up position that repressurized the landing gear, and we'd go that way until we crossed the boundary.
The 990. She was not only fast, she simply made her competitors, the 707 and the DC-8, look just bland. Although she almost bankrupted her maker, the giant Convair, with the largest write-down in U.S. history. During World War II, numerous aircraft companies excelled in designing different types of warplanes. Although in America, most four-engine land-based planes originated from just 3 companies, at least when it came to quality and quantity. They were Boeing with their B-17 and B-29, and Consolidated with their B-24, all 3 of which were heavy bombers, and Douglas with their C-54 large transport. After the war, Americans were eager to indulge in more leisurely pursuits, and they began consuming a plethora of new technologies and products. Instant cameras and microwave ovens brought the promise of a more carefree future. The airlines and aircraft manufacturers recognized that travel would become an important part of the lives of Americans, freed from the restrictions of rationing and the obligations of war. Aircraft that had delivered death were suddenly delivering passengers to sunny destinations. Post-war, the C-54 soon became known as the civilian DC-4, followed by the DC-6 and the DC-7, in an ongoing stream of stretched but excellent passenger planes. The B-29, after conversion to a military transport, the Stratofreighter, later saw airline service as the Stratocruiser. This was a useful airliner, although it never enjoyed the success of the Douglas propliners. Another interesting post-war airliner development was Lockheed's superb Constellation airliner. Though it had almost been overlooked in wartime production, it re-emerged as a peacetime winner. In this period of transition, Consolidated, which soon became Convair, seemed to abandon large propeller transport aircraft with the exception of a single example, the largest type ever made, the experimental XC-99. This monster proved that extremely large aircraft could be made, although only one ever was. So 3 proven U.S. propeller-driven airliners came to dominate the post-war civilian market. The extremely successful Douglas series of C-54s, which always seemed to be getting longer, Boeing's less-than-stellar Stratocruiser, and Lockheed's revitalized Constellation. For a decade, these sturdy types led the world in establishing passenger air transport for business and pleasure, and to an extent never previously dreamed of. These mainstays of the era's airlines were all straight-wing types, and so too were their military counterparts. Even the first-generation post-war fighters and bombers, many of which were jet-powered, shared the same cruciform shape as wartime propeller-driven types. Aircraft like the 6-engine Martin XB-48 would have been typical of the time. Then, suddenly, all that changed. Allied countries gained access to advanced German designs, including a number developed in their 1,000-kilometer-an-hour wind tunnels. Within this cache of advanced data were conclusive facts that proved aircraft could fly safely, much closer to the speed of sound, by using the assistance of a swept-back wing. However, there were risks with the swept-back wing, risks the military were prepared to take for more speed, but it was still a tough sale. Boeing was one of the main champions of the swept-wing concept. Their XB-47 Stratojet had both wings and tail sections fully swept. Later production versions could reach speeds exceeding 600 miles an hour. Unfortunately, low speed handling was poor, and jet fuel consumption was very high. Nevertheless, over time, hundreds of Stratojets would go into production, though they would all require some form of regular in-flight refueling for their critical missions to be successful. This disadvantage of poor low-speed handling would prove very problematic because all of the Air Force tankers at that time were Boeing KC-97s, straight-winged, piston-powered aircraft which were close relatives of the less-than-successful Stratocruiser. The incompatible nature of the two aircraft was brought home by the fact that the B-47s had to drop down to dangerously low speeds and altitudes to couple with the slower tankers. The Air Force needed a swept-wing jet tanker, and nobody knew that better than Boeing. Whilst the swept-wing revolution was underway, in the military, Douglas and Lockheed were quite happy to maintain their existing product lines. Fairly regular upgrades of their base products provided something new to sell, with a comparatively small increase in cost for the buyer. And if a major rework was to come, it need not be so radical as a brand new pure jet with swept wings. Rather, a straight wing configuration able to support the new jet turboprop would represent sufficient progress.
In the 50s, there was quite a different mindset. The general view was that turboprops were going to be more useful in long haul because they were less thirsty and therefore they could build them with longer range. You had aircraft like the Lockheed Electra and the Bristol Britannia occupying the turboprop routes. And they did a pretty good job on the whole on some quite long routes. You can't forget El Al used to serve Tel Aviv, New York nonstop with the Bristol Britannia, which is, again, unthinkable today.
The turboprop was a safer as well as a more economical aircraft to fly than pure jets. The proof of this could be found on the other side of the Atlantic in Britain, with a thoroughly successful Vickers Viscount, a medium-range type that sold in the hundreds to a worldwide market. With its 4 Rolls-Royce Dart turboprops, there was nothing to compete with the Viscount's speed and comfort. Even more support for similar turboprop airliners came when Vickers announced the development of an expanded Viscount, the Vanguard, and Bristol Aeroplane began production of the Britannia. All three used fairly conventional layouts and economical jet-driven propellers. Douglas were totally in favor of the straight-wing prop jet philosophy. Apart from anything else, they were smoother and faster than earlier piston types, and with straight wings, just as easy to land and take off. Later, Lockheed also looked to the straight-wing turboprop formula, and eventually committed substantial funding to design and produce their Electra turboprop airliner. However, the 1950s saw life continue to speed up for consumers. The newly invented credit card made it easier than ever to spend. Ray Kroc franchised McDonald's, kicking off the fast food era. Even the music of the time was faster with the birth of rock and roll. Did consumers have the same need for speed when it came to air travel? A visionary leader at Boeing realized the first company to meld speedy jet engines with passenger planes would dominate the airliner market. Not all companies were eager to develop jetliners. Lockheed continued to make Constellations right up until some airlines were actually ordering pure jets, and they never offered one of their own, preferring to go the way of the smaller turboprop, as defined by Douglas and practiced by the British. However, Boeing, which was hardly established as a major supplier to the airliner business, saw a chance to utilize its vast experience with jet bombers to produce tankers for in-flight refueling and ultimately jetliners. As more jet bombers came online, Boeing knew a jet tanker would be required, so using their own money they developed an aircraft that could serve this function, and also perhaps that of a jet passenger aircraft. The president of Boeing, Bill Allen, knew that if he could sell his tanker to the Air Force, much of the cost of a new passenger aircraft would be reduced, as much of the R&D would be shared between both projects. This was a very brave gamble. Douglas, with its long-standing relationships with many of the world's airlines, based on hundreds of past sales, would have been well connected to launch a successful new jet airliner to compete with Boeing, although it had never actually planned to create one so soon. Boeing quietly produced its Dash 80 prototype that might serve both military and civilian masters. There was little choice but to sweep its wings and to use pure jet power, as it had to keep up with similarly equipped Air Force bombers. The civilian version, too, benefited from this technology. In 1954, when the U.S. Air Force announced that, on the strength of a single privately funded Dash 80, it would order several hundred swept-wing jet tankers, Douglas was totally shocked. Boeing had scored a major win from the military. However, to Douglas, the major threat lay in the possibility that Boeing might convert its new KC-135 tanker into a pure jet airliner and skip right past the planned Douglas straight-wing turboprop airliners. The Douglas response was to rush forward with plans for their own pure jet passenger liner. At first, the four-jet swept-wing DC-8 seemed to have a reasonably promising future. After all, for years, the company had done so well selling earlier DCs to clients all around the world, something that Boeing had never been able to emulate. And now, with Lockheed going in another direction, they should have an even greater advantage. Inevitably, Boeing soon announced their passenger jet, the 707, and very importantly, Dash 80's development was well underway while the DC-8 lagged behind.
Boeing and Douglas were certainly more adventurous, with going straight for the jet, swept wings, potted engine configuration. And of course, they must have realized that the jet engines that they started with would not be the jet engines they would finish with. So the development forced the efficiencies in the jets by Pratt & Whitney and General Electric and others, and Rolls-Royce. So the 707 and DC-8 did become transatlantic airplanes with great non-stop capabilities as a consequence. And once they got into service, the others didn't have a chance.
It was into this competitive turmoil that Convair decided to enter the large passenger jet business. From a strictly commercial point of view, the company did have an edge. Like Douglas and Lockheed, they had cultivated a long list of airline relationships virtually on every continent, although theirs was a shorter range product, the CB-240. Originally envisaged as a replacement for the Douglas DC-3s, 240s evolved into a major commercial success with nearly 1,200 examples produced. Often known as the Convair liner, the new aircraft offered such features as tricycle landing gear for greater passenger comfort and safety, a pressurized cabin, as well as a built-in air stair avoiding the need for outside steps. The Convair liner's financial success was well recognized by Convair shareholders. However, by the mid-50s, sales of twin-engine piston-powered airliners were slowing down. The latest upgrade, the 440, was starting to be less competitive in its class.
The Convair 240, which became the 440 Metropolitan, which eventually became the 580 when they installed turboprops. All three aircraft were good aircraft. They survived very well in service with the airlines who loved them. And as a matter of fact, even today, the Convair 580s are still in service in secondary roles, for instance, firefighting. Of course, its economics started to suffer in airline service from about the late 60s.
Knowing this, Convair's commercial business division was starting to look for other products to sell to its much-prized client list. The fact that its only real post-war commercial venture had been a replacement for the pre-war DC-3, and its competitor had consistent experience with large four-engine airliners, seemed not to matter. In one single step, Convair's offering went from an early post-war propeller-driven short-range aircraft to a sleek, extremely fast four-engine swept-wing jetliner, and a good-looking one at that. A true vision of speed and beauty, perhaps the biggest leap forward for any commercial manufacturer of that time. But how did Convair think they could possibly achieve advantage over such established large transport competition? And how would the Convair jetliners compete against 707s and DC-8s? Their answer was with greater speed and perhaps a little more style. Nothing as radical as the Concorde of almost 2 decades later, although perhaps going just a fraction in that direction. Well, if in 1955 Convair's civil airliner division looked a little slow, just across the way at Convair's military aircraft division, things were anything but. The Cold War was ensuring that the U.S. Air Force had a steady demand for all types of aerial weaponry, including supersonic jet fighters and bombers. The F-102 Dagger advanced fighter was an aircraft designed around a new delta wing shape. The Dagger's purpose was to be the new backbone of American defense against Soviet bombers. By necessity, it would have to be thoroughly supersonic. It also had to carry the latest missilery. At one stage, its communication system became so sophisticated that the aircraft could be totally controlled directly from its ground base without the aid of the pilot. Still, even with all these advanced electronics, the first prototypes actually had trouble even breaking the sound barrier. Greater attention had to be applied to a new type of aerodynamics before it could fly at Mach 1. For all that, the Dagger was produced in large numbers and was later developed into the Mach 2 106 Dart, an aircraft which is generally considered one of the best defense interceptors of the Cold War. Another Convair highly advanced delta wing product, the Mach 2 B-58 Hustler, was also developed from the mid-50s onward. The Hustler was the United States' only dedicated supersonic plus jet bomber to go into full production. With 4 powerful General Electric afterburning jets, Convair's B-58 could fly as fast as any fighters of the time. Convair learned much about very high-speed flight with the Dagger and the Dart. But the Hustler also taught lessons in high speed with large aircraft, all of which the company expected to find very useful as it approached the problems of making a modern jet airliner for the first time. .880s went into production just as the 440s were coming off the line. It was hoped that one old successful product would simply be replaced with a new one. A major feature of the latest one would be its speed. .880s were expected to fly in excess of 630 miles an hour. Much of the reason for this speed was the fact that its 4 jet engines were civilian versions of the very power plants that powered the supersonic B-58 jet bomber. Only the .880 would not have the afterburners critical for the Hustler's remarkable Mach 2 ultimate top speed. Other points of commonality certainly would not be overlooked by the marketing staff of Convair or any of the airline clients. An interesting irony is that the B-58 was intended to replace the B-47, the very aircraft that Boeing used to spawn the swept-back wing concept and set the standard for nearly all jetliners to follow, including the .880. Given that Boeing and Douglas were both aiming for the long-range international market, Convair could see wisdom in designing their jetliner more for the medium-range intercontinental market. Although as a safeguard, there was a provision for extra fuel tanks to be fitted in the midsection of the wings. If really necessary, this would provide for a range of 3,250 miles, which would make it competitive with the early 707s and DC-8s, although the Convair aircraft would be carrying less passengers. At the time that the first swept-wing jetliners were evolving, it was generally accepted that seating in the coach section would be 5 across. However, in Britain, a competitor to the U.S. designs was evolving in the form of the Vickers VC-7. It had a swept-wing shape, 4 jet engines, and one feature that gave the American company something to think about. Its one major advantage was that it had 6 seats across in coach, 3 on each side with the center aisle dividing them, offering a more balanced look to the cabin and a greater number of seats for the airlines to sell. As soon as U.S. manufacturers became aware of Vickers' approach, Douglas and Boeing immediately committed to a radical and expensive widening of their jetliners. Evidence of this change can still be seen in Boeing's tankers.
It's not well known today, but the fuselage of the military version, the C-135 and the KC-135, is in fact narrower than the civilian 707. And the reason was that Boeing wanted to get 3 and 3 seating configuration in economy to squeeze in the maximum number of passengers.
Though Boeing and Douglas were anxious to make the seating change, Convair deliberately retained their narrower fuselage in the interest of greater speed. As it happened, the VC-7 never went into production, although it probably had as much impact on the evolution of future airliners as any aircraft ever had. It would take 2 years and 9 months from the start in April '56 to first flight in January '59 before the first .880 was finally ready to enter the 4-jet passenger market. The Boeing 707 and Douglas DC-8 became icons and legends in the 60s and 70s. With their swept wings and blazing jet engines, they ferried passengers around the globe at incredible speeds for the time. However, there was a third competitor that fought for a place on the podium next to these 2 champions. Supersonic jet manufacturer Convair built a pair of stunning aircraft as beautiful as they were fast. Would their good looks and speed be enough to topple 707s and DC-8s from their lofty mantle in the skies? Despite the option of an extended-range .880, they were not really intended to compete directly with 707s and DC-8s. Rather, they were medium-range and now lighter, smaller, and expectedly faster than the larger alternative. In service, .880s did prove to be the fastest, although at 615 miles an hour, only by a small margin. Eccentric millionaire Howard Hughes played an important role in the 880's development. For years, he had held secret meetings with the plane maker about a new commercial jetliner. After going through many iterations, this aircraft morphed into the 880.
Howard Hughes owned TWA, and TWA was a launch customer for the 880. And of course, Howard Hughes, if he hadn't made that leap, I doubt the 880 would have been built, because my recollection is that the launch orders were slim.
Other major airlines started to follow TWA's lead, although not in really large numbers. There seemed to be a market for the medium-size aircraft, even though the larger international range alternatives had been available 18 months earlier, and they offered much greater carrying capacity. But this would soon change. Although many agreed that Convair's offering was the most aesthetically pleasing of the new generation airliners and definitely faster, survival in the passenger airline business has always been a matter of economics. Still, the rationale of Convair's short-range formula was actually confirmed within 12 months of the 880's first flight, albeit in a rather bitter way. Although the 880 wasn't primarily intended to compete directly with Boeing's and Douglas's larger jets, this didn't prevent these two powerful commercial plane manufacturers from taking a bite out of Convair's short-range market. Through the years, Boeing would increase the length of its 707, but just as the 880 was getting started, Boeing produced its 720. The 720 was in fact a shortened version of the 707. A sizable length of the forward body was removed, and there were other modifications to follow suit, but in essence, it was a smaller, lighter, and shorter-range 707. What's more, because most of the R&D came from the larger model, and much of the testing was done on the original Dash 80, there was no need for a new prototype. All of this made 720s a cheaper aircraft than the 880.
Boeing introduced the 720, I think, primarily, in retrospect, as a Convair killer. It was a short-body version of the 707 with a different wing and less fuel, and again, basically became a regional aircraft. The airlines liked it because it had the same cockpit as the 707, and their crews could be interchanged, which is, of course, a fashion that's very much in vogue today, where Airbus and Boeing build airplanes that are common up and down their line.
150 720s were sold, more than twice the number of 880s. Although the success of the 720 did prove that Convair's medium market theory was sound, Boeing became the major benefactor, even though they were new to the airline industry. Desperate to sell 880s, Convair turned to its engineers to see if they could make it more appealing to buyers. The result was the 880M.
The 880, the 22, the straight 22, was a slick wing. It had no leading edge devices at all, and it had speeds compatible to probably the 727. Then the 880M, which they put an extra fuel tank in the center, which gave them just about 10,000 pounds of extra fuel, plus it had leading edge slats.
The addition of leading edge devices made the 880M safe to land at lower speeds. But even with this, its extended range and other changes, Convair still had a tough time competing with the 720s and 707s. Although the 880 fell out of favor with the airlines, it was the aircraft of choice for the king of rock and roll. Ron Strauss, Elvis Presley's pilot, recalls how the king came to purchase his own 880, the Lisa Marie.
Originally, Elvis bought a 707. But his attorneys advised him that if he bought that, and some of the countries that he could go to in that, they would put a lien on it, and that would be the end of that airplane. So the broker was showing him different airplanes, and he looked at an 880, and he says, "I like that." And the broker says, "You really don't want an 880." And he says, "Well, I do." And he said, "Well, why do you want the 880? He said, "I like the way the engines look on it." And that's the reason he bought it, supposedly. He actually bought that airplane from Boeing because Delta traded it in for new Boeing 727s. And so he bought it from Boeing for $225,000, which was pretty cheap, really. But then he put about $500,000 into the airplane. interior and the cockpit, etc.
Though the 880 was a financial disappointment, Convair wasn't finished yet. The company had 2 speedy planes in the works. Both would leave the 707s and DC-8s of the day in the dust, and one might have given the Concorde a run for its money. In the 1960s, there was a growing fear that the existing stable of American-made long-range airliners would become obsolete with the arrival of the supersonic Concorde. Convair proposed a quick and dirty solution for getting into the supersonic market. They already had plans for an enlarged Hustler, the B-58C. What if they used its basic shape and filled it with passengers rather than bombs? The new Model 58-9 would have been able to travel at Mach 2.4 and carry up to 52 passengers 2,900 miles, about the distance from New York State to California. As a baby step toward this aircraft, Convair would hollow out the weapons pod of the Hustler and convert it into a comfy passenger pod. It would have had windows, pressurization, AC, and seating for 5, changes the original pod designers would never have dreamed of. It would have been a clever and inexpensive way to learn about high-speed passenger travel without building a full aircraft. Convair's other fast plane was far more conventional and built upon the foundation of the 880. At the time, American Airlines had identified the need for a true coast-to-coast non-stop service across the U.S. The 60s were quickly approaching, the era of beach movies, the Beach Boys, and bikinis. Traveling from the snowy Northeast to a sunny California paradise was a dream airlines could easily sell to their passengers. To meet American Airlines specifications, Convair's redesign would have to be even faster than the original 880, a challenging task as it was also required to carry additional passengers. The new aircraft would now be known as the 990 or the Coronado.
Convair recognized that the 880 had missed the mark in terms of positioning, and market positioning as we call it today, and they needed a bigger aircraft and longer range. American Airlines certainly, as the launch customer, was looking for that, and they ordered the first batch of 990s early on, and it was intended to be a transatlantic airplane with, and also of course very fast. Both of them were very fast aircraft. The 990 I believe was the fastest airliner at the time.
The extra seats requested by American would be achieved by simply extending the forward fuselage by 10 feet. However, the real challenge came with increasing the 990's top speed. This might be a tall order for Convair, even with its extensive military experience. Firstly, Convair would tackle the power plants. 880s used a slightly defanged version of the Hustler's J79 turbojet made by General Electric. Given that the B-58 had the capability to reach twice the speed of sound, it's reasonable to assume there would be plenty of surplus power for the very fast subsonic airliner. However, the Hustler's engines also used afterburners, something the first-generation jet airliners could never do. By promising extra speed to American Airlines, Convair had to look to GE for extra thrust, and this came in a really clever development.
The 880 had the CJ805, which was just a straight early version jet. Then the 990 came out with the same engines that the B-58 had, but the B-58 had afterburners on them. The 990 had the CJ805- I think 23s, and they had the aft fan.
GE took the original 805 turbojet and added a fan turbine system at the back of the engine. The turbine was driven by the main jet's exhaust flow and turned a special fan that converted additional cold air into extra thrust. The net result was greater power for no extra fuel. The new fan jet was known as the 805-23. More thrust with greater economy sounded like the answer for Convair. By drawing on their military experience yet again, they had still one more card to play. In 1953, Convair began testing its prototype F-102 Dagger supersonic fighter. The results were poor, and the aircraft proved to be a long way short of supersonic. The 102 was encountering a phenomenon known as transonic drag on the fuselage. The problem was solved when an aerodynamic formula known as the area rule was employed. The fuselage was indented at the point where the wings joined with it, giving a Coke bottle look to the aircraft, a change which got the Dagger through the sound barrier. Unfortunately, transonic drag could start to occur around the top speed at which the 990 was expected to fly. Of course, the fuselage of an airliner could not be bent into a Coke bottle shape like a fighter jet. However, there were other options. Enter the anti-shock body. This was designed to deal with the transonic drag problem from the wing. Aerodynamic pods mounted on the trailer edge of each wing would smooth out the airflow and reduce drag. Sometimes known as Kuchayman's carrot, after one of its German inventors, the concept was first seen in early Soviet jet bombers.
What happened without the anti-shock bodies, the 990 was so fast that when you approached the critical Mach number, you would get a vibration in the fuselage. So what they did is the engineers designed these anti-shock bodies, and that prevented that operation. And then somebody got smart and said, well, why don't we put fuel in those things? And we did. We put about 10,000 pounds total. So that gave us just about, on cruise, that gave us an extra hour of cruise. And they worked pretty fine.
In the quest for speed, Convair engineers swept back the wings of the 990 even more than the 880, a change that forced pilots to remain alert to avert a disaster.
The 990 had 39-degree sweep, where the 707, 880, and the DC-8 had approximately 35-degree sweep. So it had a tendency to Dutch row. And on a Dutch row, if you put incorrect recovery procedure or not soon enough, it would progressively get worse where it could go inverted. So the 990 was, you had to pay attention on the Dutch row.
More powerful engines, greater wing sweep, and speed pods on the wings all should have offset the extra weight of a longer cabin. However, the speed boost was not impressive. It was almost a rerun of the earlier XF-102 disappointment, only this time the area rule had already been applied. There was no third chance for Convair in a U.S. airliner business already carved up amongst other players. Soon 707s and 720s would be available with turbofan engines, blunting the 990's competitive speed edge. When the 990 failed to reach its promised target to American Airlines, the company reduced its original order.
It didn't stay in service with American for very long. They replaced it with the 707. Its economics just didn't compare at all. I think the Convair was highly regarded for its structural strength and fatigue resistance, but the fuel consumption was just not competitive against the more modern 707 and DC-8.
All told, a total of 37 Coronados were sold mainly to American, Swissair, and Scandinavian SAS. Add to that the 65 880s Nets 102 airframes in total. With so few sales to amortize the development and tooling costs, Convair was facing colossal losses. At that time, it was the largest financial write-down in U.S. history. So what went wrong for Convair?
It was fundamentally incorrectly sized for the market, and therefore the only way to correct that would have been to start again with a clean sheet, which would have been an expensive project and presumably beyond their financial resources at the time. It certainly ended Convair's excursion into civilian aircraft production.
The success of the 707 was undoubtedly influenced by Boeing's past relationship with the Air Force and really knowing its needs. Also, a big factor was President Bill Allen's preparedness to gamble on the back end of the jet tanker deal to get his company into the airline business. On the other hand, when Boeing, through necessity, skipped right past the straight-wing turboprop option, they left other companies with little choice but to follow. Douglas were already about as close to the long-range passenger market as any company could have been, and, where possible, used this fact to make up the difference of their being later to the market than Boeing. However, both companies were quick to make major and expensive adjustments to their designs, so they could stay abreast of the 6 seats across requirements. There was actually a fourth player in the long-range jet airliner race, which also had ample seating: the sturdy Vickers VC-10, a descendant of the VC-7. But the Brit jetliner couldn't compete with the aviation giants Boeing and Douglas, who quickly saturated the market with their own offerings. Convair's extra speed edge was declined in favor of guaranteed extra passenger dollars offered by Boeing and Douglas.
The fuel that they got per seat mile was much larger on the Convair 990 and 880 compared to the 70 and the DC-8. And airlines were talking profit, and that's where the profit was strictly in seat per mile.
Another blow to Convair's slightly narrower concept came when Boeing introduced their shorter size and range 720 version of the basic 707. This fitted very closely to where Convair had looked for market safety. Conversely, although at first Douglas resisted stretching their new jet passenger plane, it eventually had little choice in doing so to satisfy a fast-developing jetliner market. In the company's time-honored way, it extended the DC-8's fuselage on several occasions in the same fashion that had worked so well with their famous series of 4-engine propeller-driven airliners. There is more carnage that can be traced back to when Boeing first opted for a swept-back wing. Whilst some post-war turboprops were successful, others were not. The straight-wing British Vanguard and their Britannia never reached anything like the sales predicted. And in the U.S., Lockheed's Electra suffered an economic fate nearly as bad as the 990. Clearly, the market was looking for the extra speed of pure jet power. Convair's even faster airliner, the proposed Supersonic Transport Model 589, had an even more grim fate. The design didn't meet the performance benchmarks the U.S. government was looking for. The aircraft would have been able to reach Mach 2.4 only. Mach 3 was considered the optimal speed for supersonic passenger transport. Also, it would not have been a comfortable ride. Essentially, the 52 passengers would have been crammed into an enlarged B-58 bomber's slender fuselage. Even if Convair had been chosen by Congress to develop the aircraft, all SST development came to a grinding halt in the U.S. Beyond the problems of sonic booms disturbing the public and shattering windows, the aircraft were not economical for airlines to operate. The disappointments of the 58-9, 880, and 990 put Convair out of the civilian market permanently. Still, with its long, slim fuselage and trailing wing pods, the 990 was a vision, although good looks don't always make a successful aircraft. In the end, it was the 707, followed closely by the DC-8, that would become the iconic jetliner of the 60s. It captured the imagination of the public as it ferried leaders, celebrities, and ordinary people to the key moments of that turbulent and magical decade. Although the 990 had been resoundingly defeated by the 707s and DC-8s in the battle for jetliner supremacy, in 1970 and 1971, the 990 accomplished a first for passenger aircraft. Modern air transport created a unique round-the-world ticket to take high-rolling passengers to every continent of the world. However, it was the boldest of routes over the poles. It was not an inexpensive ticket, $10,000, but it was well worth it to the flight's 70 all-male adventurers, a mix of millionaires, playboys, and retirees. Modern Air Transport's 990s served as aircraft for this month-long journey in honor of polar explorer Rear Admiral Richard E. Byrd. It was a small victory for an aircraft with an underwhelming career, and yet with so much potential. In 1975, the last of Swissair's Coronados, nicknamed St. Gallen, was officially retired. She took her last voyage, not by air, but by water, across Lake Lucerne on a specially built barge. Swissair's 990s had crisscrossed across Europe, the Middle and Far East and South America for 13 years. Fittingly, after so many years of service, St. Gallen was given a place of honor after her retirement. The jetliner now resides at the Swiss Museum of Transport, where she still catches the eye of visitors with her elegant lines. With the aircraft frozen in mid-air, they can only imagine her incredible speed in a bygone era.
In 1952, Boeing took a huge gamble by developing a prototype jet transport aircraft, risking more than the company's entire net worth on the project. Had the new aircraft failed, it could have led to the company's downfall. However, the 707 family ultimately became one of the greatest success stories in the history of air travel. On May 15, 1954, the Boeing 367-80, now famously known as the Dash 80, was unveiled to an enthusiastic crowd of employees and guests. Despite the setbacks the British had faced with the jet-powered de Havilland Comet, interest in Boeing's project remained strong. Everyone present understood the significance of the event, though few realized they were witnessing the debut of one of the most important aircraft ever built. The Dash 80 was designed as a one-of-a-kind prototype to demonstrate the viability of jet-powered transportation. Drawing on their experience with jet bombers, Boeing's engineers created an entirely new aircraft. Featuring a wing with a 35-degree sweep similar to military jets, but far more rigid. The wing flaps were divided to prevent interference from engine exhaust. Two sets of ailerons were installed, one for high-speed cruising and the other for takeoff and landing. The Dash 80 featured a tricycle undercarriage, with two sets of main wheels that retracted into the fuselage and a double nose wheel. Powered by 4 Pratt & Whitney JT3 turbojets, which were the civilian counterparts of the engines used in the B-52. These engines were mounted in individual pods positioned below and ahead of the wings. This configuration not only improved weight distribution, but also made maintenance easier. The hinged side panels of the nacelles provided convenient access to the entire engine. Taxiing trials started almost immediately. But on May the 22nd, the Dash 80 encountered an issue when its port undercarriage collapsed. While the structural damage was minimal, the incident delayed the test program by 6 weeks for repairs. The Dash 80 measured 127 feet in length, with a wingspan of nearly 130 feet. Its cockpit was designed to hold a pilot, co-pilot and navigator, but the cabin did not feature standard passenger seating. As a purpose-built experimental aircraft, it had very few refinements. The fuselage interior was virtually bare and featured few cabin windows. Boeing had invested 2 years of secret development into the aircraft and had a clear vision of what they wanted to achieve. Tex Johnson, Boeing's senior test pilot, was selected to fly the Dash 80 on its much-anticipated maiden flight, which took place on July 15, 1954. As the crew worked through their checklists, they carried the company's future on their shoulders. In theory, both military and civilian markets held great potential for the aircraft. However, Boeing had been cautious and slow to enter the commercial market, partly due to resistance from both the traveling public and airlines toward jet airliners. Additionally, Boeing was heavily focused on the development and production of bombers. With the Dash 80, Boeing not only committed to the commercial market, but also gained a significant advantage over its competitors. Boeing's board made the decision to build the aircraft on April 22, 1952, convinced that the US Air Force would eventually need jet transports. They believed that a well-designed jet could serve both military and civilian markets. Powered by 4 turbojets, the Dash 80 lifted off after using just 2,100 feet of runway. Johnson, the test pilot, later remarked that the plane wanted to climb like a rocket, and he had to throttle back to stay within the airspeed limits for the maiden flight.
After flying the B-47 and the B-52, there was no doubt in my mind that the aircraft of the future, military and civilian transportation, was going to be jet. Of course, the prototype 707 was all built with company money, and it was a big responsibility. It was a gamble to some degree from a structure standpoint and a performance standpoint, but not nearly as much as the gamble of how long was it going to take the airlines to decide that's what they wanted and come up with the money to produce them.
Tex Johnston, Chief of Flight Test for the Boeing Airplane Company, signed for the new jet transport and climbed aboard with Dick Flesh, his co-pilot.
With half of Seattle out there observing it, and all of the industry, airlines, engine manufacturers, competition looking down your throat, you had a lot on your mind. But once you fire up the engines and taxi out for takeoff, all that leaves you, and you're primarily absorbed in all the systems in the airplane, how it's reacting to the control. And as we taxied out, the people were jumping up and down and waving, and it was a celebration.
We're clear to come up on power.
We gave it the power, it took off, it rotated, and the first lift off, the airspeed just kept building. I kept pulling the nose up, and we were light, relatively light, you know, and we were climbing steep. And my co-pilot, Dick Slesh, said, "Man, is this thing going to climb straight up?" And after I landed, some of the engineers said, "We thought something was wrong with the control system. The airplane was climbing so steep. All I was doing is keeping on the best climb speed."
Flight test reached 36. We've been climbing for 8,700 feet. All engine operation is normal. Hydraulic pressures are normal. The airplane feels good. The airplane taxied in, and when it had been parked, the pilot and co-pilot were congratulated by William M. Allen, president of the Boeing Airplane Company.
I could see the difference in that man from, he shook hands with me before I climbed aboard on the initial flight. And to me, it looked like he was carrying a bit of he was stooped a bit at a load he was carrying, mentally and financially. When we landed at Boeing Field and he came out there, he was standing straight and tall and smiling, and it was beautiful to witness the difference in the man. IATA, the International Air Transport Association, which includes all the airlines of the world, had assembled in Seattle for their annual convention. And Boeing just happened to have a prototype airplane that was going to shrink the world by a factor of 2. But I've sold fighters and commercial airplanes, and you demonstrate them to impress people what they're capable of. And I knew the prototype, and there's one maneuver that you can do with no hazard whatsoever. I decided that I would do a roll to impress the people. So I came across and did it with Chandel. One of my test engineers happened to have his camera with him, and he snapped a picture, which is famous today, with the airplane on its back, the engines up on top of the wing, and the Lake Washington below. I was called to Mr. Allen's office Monday morning, and Mr. Allen asked me what I thought I was doing, and I said I was selling airplanes. And explained it's a 1G maneuver, and it's absolutely non-hazardous, but it's very impressive. And his comment was, you know that now, we know that, but just don't do it anymore. So it was fine.
The first test, which was smooth and uneventful, lasted only an hour and 24 minutes. In the next 8 days, the aircraft logged a total of 15 hours and 46 minutes of flight time. As the speed and altitude capabilities of jet fighters and bombers increased, they were forced to slow down and descend when refueling from piston engine transports. It didn't take long for the USAF to assess the Dash 80 and recognize its potential as a refueling tanker. Air-to-air refueling had become increasingly crucial, especially with the expansion of the jet fighter fleet during the Korean War, and the existing piston engine tankers were clearly insufficient. The need for an all-jet tanker was apparent, and the Dash 80 arrived at the perfect moment. Just 3 weeks after the Dash 80's first flight, and before it had even been tested as a tanker, Boeing received a contract from the USAF for 29 aircraft. This contract provided a significant morale boost for Boeing, especially since there had been little interest in the civilian variant at the time. The Dash 80 was soon equipped with a modifying flying boom, and a successful refueling test program quickly commenced. On October 5, 1954, the military version of the aircraft was officially designated the KC-135A when the contracts were finalized. Although the initial military order was relatively small, the potential was vast. In late 1953, the USAF had already begun seeking proposals to supply the Strategic Air Command with a jet tanker fleet to extend the operational range of its B-47 and B-52 bombers. 6 companies had been invited to make formal submissions. The USAF tender actually called for the provision of 800 tankers. The stakes for Boeing were immense. While the Dash 80 continued its test flights, production of the KC-135A began at Boeing's Renton factory. Though it was impossible to predict at the time, the KC-135A would remain in production for the next 10 years, with 732 units built in total. The KC-135A models were all equipped with upgraded Pratt & Whitney J57 turbojets and had an impressive fuel capacity, with up to 21 fuel tanks. The aircraft could also transport up to 160 troops or carry 83,000 pounds of cargo. Recognizing the strategic importance of polar regions, Boeing produced a specialized version of the KC-135A for Arctic operations. This version was designed to allow the crew to live aboard for weeks without needing ground support. Featuring a living area, bunks, and food storage facilities. The first production KC-135A Stratotanker was rolled out at Renton on July 18, 1956. The basic design of the KC-135A remained largely unchanged from the Dash 80 prototype, with the same overall dimensions. The first KC-135A tanker took flight on August 31, 1956. After undergoing initial testing, it entered service with the Strategic Air Command by mid-1957. The Stratotanker was notable for its lack of windows and its boom operator's station, with the high-speed refueling boom neatly mounted beneath the rear fuselage, As a military aircraft, the KC-135A was built to meet performance and safety standards that differed significantly from those required for civilian aircraft. Its J-57 turbojets, equipped with water injection for additional thrust, produced intense noise and thick sooty smoke during takeoff. With a gross takeoff weight of 316,000 pounds, the KC-135A required a runway length of 13,600 feet, much too long for civilian airports. The KC-135A's airframe was constructed from a different alloy than the commercial variant. Its refueling system, the flying boom, was a Boeing innovation. The boom itself is 27 feet long and extends up to 46 feet, made of concentric tubes. The boom operator, positioned in the tanker, controls the docking process by maneuvering the boom into place. Once contact is made with the receiving aircraft, fuel is pumped from the KC-135's tanks through a series of valves and a pressure regulator, then into the boom and finally into the receiver. Standard speed booms could be swapped out for high-speed versions, designed to refuel faster aircraft like the SR-71 Blackbird. Boeing's contract with the Air Force gave the company the confidence and financial stability to further pursue the profitable civilian market. Pan American became Boeing's first 707 customer, when it placed an order for 20 aircraft in October 1955. To Boeing's delight, Pan Am also ordered 20 Douglas DC-8s on the same day, even though that plane wouldn't fly for another 3 years. The inaugural 707 airline service was launched on the 26th of October 1958, when Pan Am flew 111 passengers from New York to Paris. Soon after, American Airlines launched the first scheduled passenger jet service from Los Angeles to New York. This cut the flight time across the US to about 4 hours, effectively halving it. In the first 18 days of operation, American Airlines transported 3,720 passengers, achieving an impressive load factor of 99.5%. The use of doors at both ends of the cabin allowed for quick boarding and disembarking, a significant advantage that necessitated changes in airport design and operations. The initial 707s were designated as the 707-120. Although the 120 model was primarily designed for domestic routes, Pan Am used it for transatlantic flights. The cabin could accommodate 121 first-class passengers or 179 in economy. With the introduction of longer-range 707 models, most of the 120 series aircraft were reassigned to domestic services. The 707's spacious fuselage and excellent performance quickly won favour with both passengers and crew. Its ability to fly above weather conditions, which propeller-driven liners had to navigate through, offered smoother, faster and safer flights. The cabin of the 707 could accommodate twice as many passengers as the older Constellations, making air travel a viable option for a growing number of travellers. Jet travel not only displaced competition from propeller-driven aircraft, but also heralded the decline of passenger ships, which even into the 1960s carried more travellers than holidaymakers. It's no exaggeration to say that a transportation revolution had begun. The competition soon intensified, with the emergence of the Douglas DC-8, the Convair 880, and various European models. Boeing was compelled to initiate a program to develop even more advanced jetliners. The initial risk of $15 million had been far surpassed, with new stakes approaching $100 million. Although Boeing maintained a significant production lead with the 707, Douglas gained traction with the DC-8 by promising greater payload capacities, longer range, more powerful engines, and other benefits for airlines and passengers. While Pan Am and American Airlines operated the 707-120, Boeing was already working on another important version of the aircraft. In response to the Douglas challenge, Boeing had announced the development of a new 707, offering greater range and capacity, the Intercontinental 707-320. In a hydrostatic test tank, The fuselage of the Intercontinental 707-320 was subjected to conditions equivalent to 40 years or 50,000 flight cycles. During testing, the fuselage was intentionally torn open and then subjected to cycles of extremely high pressures and heavy loads. Despite this, the damaged structure endured the stress without sustaining further structural damage. The 707-320 made its first flight on January the 11th, 1959. The success of the test series was so significant that just 35 days later, the aircraft was handed over to the Federal Aviation Agency, FAA, for certification trials. At Edwards Air Force Base in California, the Intercontinental underwent rigorous testing. It wasn't allowed to carry passengers until it received a certificate of airworthiness from the FAA. FAA test pilots conducted a thorough evaluation of the aircraft's flying characteristics, while ground engineers measured the performance of every component. The test team pushed the aircraft to its limits, flying it at altitudes ranging from low levels to the stratosphere, and at speeds from near stall up to 700 miles per hour. The Intercontinental 707-320 was over 12 feet longer than the 707-120 and featured a wingspan nearly 12 feet greater. It was the first model to be truly intercontinental, directly challenging the claims made by Douglas for the DC-8. Equipped with powerful Pratt & Whitney JT4 turbojets, the aircraft was capable of carrying a payload equivalent to 189 passengers. One of the final FAA tests involved installing ballast tanks in the cabin, filled with water to simulate the weight of 180 passengers and 45,000 pounds of payload. An additional 9 tons were added for extra measure, bringing the total weight of the aircraft to 316,000 pounds, a significant challenge for the FAA team of pilots, engineers and technicians. On the test day, conditions were ideal for a maximum weight takeoff, and the powerful turbojets required only 2/3 of the runway to lift the Intercontinental into the air. The 707-320 was also offered with the Rolls-Royce Conway Mark 508 turbojet as an engine option. BOAC was among the first to choose this engine, partly because it was a British product. The decision to purchase a 707 instead of a British aircraft had political implications. During the trials for its British certification, several extensive modifications were required, including a taller fin and a power-assisted rudder. These changes were later incorporated as standard features on the production line. The final test flight, conducted under full airline operating conditions, marked the first truly intercontinental flight of the jet age. The Intercontinental 707-320, sporting its new Boeing livery, was destined for Rome, Italy. William Allen, the chairman of Boeing, had good reason to smile. After departing from Boeing Field in Seattle, the 707-320 took a northeast route along the Great Circle Path. It flew over Canada, Greenland, Scotland, and Germany, cruising at Mach 0.78 and reaching a maximum altitude of 39,160 feet. The aircraft landed in Rome just 11 hours and 6 minutes after takeoff, marking the longest flight ever completed by a jet airliner up to that point. The following day, the plane continued its journey to Paris, Frankfurt, and Brussels before making a night stop at Heathrow. The FAA granted certification on September 23, 1958, and the transport revolution advanced further. By the end of 1958, Boeing's Renton plant was producing aircraft for airlines in 11 nations. In addition to the standard 707 models, they were preparing for both the intercontinental versions and new high-speed developments. This variant would eventually be distinct enough to earn its own identity as the Boeing 720. Different versions of the aircraft were assembled simultaneously, with airline labels providing clues to their destinations. For instance, South African Airways and Varig of Brazil had orders for the Intercontinental 320, while a version for Lufthansa was equipped with Rolls-Royce Conway engines. This particular version gained popularity and was marketed as the 707-420. As production ramped up, 707 milestones were achieved rapidly. The 100th 707, adorned in the livery of Air India International, was also a 707-420. By the end of 1959, the medium-range 720s were being delivered to United Airlines. In total, 154 of this model were built in 2 different versions. Lufthansa flew back to Germany in record time. Sabena began operating 707 services to Africa and Russia. The 720 model achieved a speed of Mach 0.9, just as the designers had promised. A Rolls-Royce-powered Intercontinental 707 made history for BOAC by completing the first non-stop crossing of the North Pacific, flying from Seattle to Tokyo. Air France introduced the Model 320 on transatlantic routes, while Braniff launched a special tropical version of the aircraft. The new jets were so well received that, until sufficient numbers were in service, they were often filled exclusively with first-class travellers. Within a year of entering service, the 707 had carried over 2 million passengers. Australia's Qantas launched a new service from Sydney to San Francisco, one of many new routes established worldwide with the introduction of Boeing's aircraft. Despite significant pressure to purchase British aircraft, Qantas opted for the 707-120. Boeing had designed this short-bodied version specifically to allow Qantas to operate from Sydney's short runway, as well as the short runways of its Pacific stopover destinations. The longer routes, typically flown by Qantas, meant sacrificing some passenger capacity in favour of enhanced performance. This trade-off was more than compensated by the plane's improved range and speed. Although only 7 of these aircraft were built, they proved to be a great success. Qantas passengers experienced the Pacific Ocean journey reduced to just 15 hours. Production of the 707 series concluded in 1979. With a total of 917 aircraft across all versions built. These jets were operated by 62 different airlines, and in at least 300 of them are still in service today. One of the most definitive signs that the jet age had arrived occurred in December 1959, when a United States Air Force 707, the C-137A, landed in Rome. The jet, carrying President Eisenhower on a mission dubbed Operation Monsoon, was used for a whirlwind tour of 11 countries in 19 days, a journey that would have previously taken over a month. In Turkey, the president was welcomed by more than 400,000 people. In India, Eisenhower fulfilled one of his dreams by visiting the Taj Mahal with President Nehru. And upon arriving in Athens via Tehran, he had traversed the entire empire of Alexander the Great in just 1 day's travel. The president's journey continued through France, Spain, and Morocco before returning to the United States. The trip was a resounding success, with massive crowds welcoming him at each stop. However, its significance extended beyond diplomacy. For millions of people, it marked the beginning of a new era in global travel. Package tours have since become a common way for people to experience the world, echoing Eisenhower's journey. For Boeing, the mission highlighted the critical role of the 707. Although the military had its own version, the C-135, the USAF also acquired civilian 707s, which were designated as C-137s. The 707s replaced the Air Force's small VIP fleet, and served as presidential transports for every president from Eisenhower to Reagan.
Thank you very much indeed for coming out on this cold night to welcome my party and me back home. It's certainly good to be here. Now, I must remind you that this morning we had breakfast in Madrid, lunch in Casablanca, and now we are home at an hour which, by our getting up time, was 5 or 6 o'clock in the morning. So we need to realize that this is not a time for a very erudite and informing speech.
These planes have become historical icons in their own right. For instance, one aircraft served as Air Force One from 1962 to 1972. Its most sober moment occurred when it was used to return the body of President John F. Kennedy to Washington after his assassination. The designation Air Force One has since been assigned to other aircraft, and it's the radio call sign used only when the president is on board. The VC-137s were operated by the Air Transport Wing. Each was configured with a custom-built interior, luxuriously equipped with only 22 seats. The C-137s were equipped with advanced navigation and communication systems to ensure global self-sufficiency. By 1989, presidential duties were transferred to a pair of Boeing 747s. In contrast to the limited number of C-137s, a substantial fleet of C-135s was produced. Many of these airframes have been extensively reconfigured and used in a wide variety of roles by different branches of the military. During the Vietnam War, the C-135 series was particularly prominent, with up to 10 different variants in operation simultaneously. Several C-135s were modified to carry electronic communications and intelligence equipment under the Strategic Air Command. The EC-135s, which served as airborne command posts, played a crucial role in the air war. These aircraft were originally designed for other purposes, but were adapted to the EC-135 standard.
The EC-135 aircraft looks like just about any other C-135 series aircraft in the Air Force inventory. The big difference is in the back. This is the SAC Airborne Command Post, known as the Looking Glass. The Airborne Command Post is a scaled-down version of SAC's primary underground command post and has the same basic capabilities. On a day-to-day basis, the underground command post controls SAC's forces around the world, but it would be a primary target for a potential enemy during wartime. If the underground command post is disabled, control of SAC's forces passes to the Airborne Command Post. Its battle staff is trained to manage any counterattack the President may direct and to direct the recovery of returning bomber and tanker forces. There's an Airborne Command Post flying over the Midwest 24 hours a day. Additionally, the Looking Glass aircraft has the capability to launch the Minuteman missile force if primary launch control centers are disabled.
The Looking Glass planes, a notable example of the EC-135s, were particularly significant.
3-4, yep, turn up. Yeah, we're about ready to take off. Communications is the key element in maintaining command and control of the forces. Looking Glass is equipped with radios covering a wide spectrum of frequencies and includes the Air Force satellite communications system. At the touch of a button, the battle staff can talk to any SAC base around the globe.
An EC-135 designated Looking Glass was operated by a crew of 16.
Attention battle staff, Major General Putman is on board the aircraft.
The EC-135s were equipped to remain airborne indefinitely, featuring both reverse fueling capabilities from SAC bombers via the boom and a standard refueling point. Each EC-135 was staffed by 5 flight crew members, 10 additional personnel, and a very senior officer. Over their service life, the EC-135s have been adapted into 8 different versions, reflecting their crucial roles and the special care given to their maintenance.
Lights out.
There's certainly been a lot of changes in the Looking Glass as far as the equipment and the performance of the aircraft over the past 21 years. But the basic mission to provide a survival command and control element has not changed. I think the great achievement is that it's been airborne continuously for 21 years, and that's due to a lot of dedicated people. We have outstanding air crews, battle staff, but mainly the people who supported on the ground have allowed this to happen. The primarily the maintenance people. They have to be out here 24 hours a day to ensure that we maintain this record and we can meet our commitments.
Although they were first produced in the mid-1960s, many EC-135s remain in service today. Notable milestones in their service include providing tactical command during the 1986 raid on Libya, confirming the Chernobyl accident through intercepts of Russian communications, and playing a key role in the Gulf War. In the late 1960s, the USAF awarded Boeing a contract to convert 2 Series 320 civil airliners for military use. Upon completion, there was no mistaking the EC-137s, as both were equipped with a distinctive 30-foot diameter rotating antenna mounted above the rear fuselage. These aircraft were the first 707-based AWACS planes, Airborne Warning and Control System. The AWACS were designed to function as a combination of a radar station, communication center, and command post. They were mobile, flexible, survivable, and resistant to jamming. With their capability for long-range surveillance in all weather conditions and over all terrain types, AWACS have become a crucial component of Western defense systems. As AWACS, the military 707s have truly demonstrated their capabilities as aerial sentries. A supersonic jet traveling at twice the speed of sound would move only 1/8 of an inch in the time it takes a laser beam to travel 1 mile. At the Air Force Weapons Laboratory in Kirkland, New Mexico, an airborne laser laboratory has been established. This aircraft was converted from an early KC-135 production tanker and is equipped with a distinctive narrow hump on top of the fuselage, which houses a rotating turret at the front. The turret, measuring 5 feet in height and weighing around 4,000 pounds, is a key component of the system. The turret is capable of rotating at about 100 degrees per second. The Airborne Laser Laboratory, operated by the 49th and 50th Test Wings, utilizes carbon dioxide laser technology to test its effectiveness on various materials used in aircraft construction. Engineers and scientists who developed the high-energy laser program are on board, allowing them to operate and refine the equipment they conceived, designed, and built. This airborne laboratory is another example of the diverse roles and configurations the 707 family has undergone over the years. Since the mid-1960s, the USAF has continuously maintained and updated its KC-135 tanker fleet. A significant upgrade for these tankers was the installation of fuel-efficient fan engines, which provided greater thrust and instant start capability. The re-engined KC-135s benefited from a 30% increase in thrust, coupled with a 27% reduction in fuel consumption, 85% less noise, and 90% fewer emissions. These advancements also extended the aircraft's lifespan. Alongside the new engines, the electronic, hydraulic, and flight control systems of these updated tankers were also modernized. Among the various unique variants of the 135 series are reconnaissance aircraft featuring a distinctive thimble-shaped nose. This bulbous nose houses sensitive radar equipment, and many of these planes are also equipped with camera ports and fuselage antennas. These aircraft play a crucial role in ongoing intelligence collection. Even more unusual were the 8 EC-135Ns, which had an even more pronounced nose deformation to accommodate a 7-foot diameter dish antenna. Converted in 1967, these planes were crucial to the Apollo projects. Operating in pairs, they ensured continuous voice communication between astronauts and ground control during manned space flights. In addition, they assisted in tracking the spacecraft. Despite the numerous innovative variants, the KC-135 tanker remains the cornerstone of the 135 series. Since the re-engineering program began in 1980, the operational benefits have been significant. The re-engined KC-135RE alone saves up to $400 million annually for the USAF due to reduced fuel consumption. Enhanced fuel efficiency allows these aircraft to offload more fuel, as they require less for their own needs. In addition to the re-engineering, 33 major modifications have been made to enhance strategic readiness. These upgrades have reduced maintenance needs, enabling crews to deploy more quickly. Around the clock, every day of the year, KC-135 crews are on alert globally. During the 1986 raid on Tripoli, the tankers were crucial. They refueled the F-111s at least 4 times on their way to Libya and twice on the return journey. This capability was vital, as both Spain and France had denied the United States overflight rights. In addition to the tankers, an EC-135E provided tactical command for the raid, and another C-135 was tasked with delivering photographic evidence back to Washington. During Operation Desert Storm, both US and French KC-135s played a crucial role, providing in-flight refueling for all US aircraft as well as several Allied aircraft. The updated KC-135s, equipped with powerful new turbofan engines, benefited from a substantial increase in thrust. This improvement allows these aircraft to take off with a full load from a distance up to 2,500 feet shorter compared to earlier models. The maximum takeoff weight has been increased to 322,500 pounds. The efficiency of the new fan engines translates into significant operational benefits. The aircraft can offload 65% more fuel at a 1,500-mile radius, and an impressive 150% more at a 2,500-mile radius. Currently, the average C-135 airframe has utilized only a third of its expected 30,000-hour lifespan. There seems no doubt that the jet will still be in service beyond the current plans for their retirement around the year 2020. In 1972, the Dash 80 was retired and donated to the National Air and Space Museum. It remained in storage in the Arizona desert for 18 years due to a lack of exhibition space. The Dash 80 had been a pioneer in modern jet transport and a testbed for new aircraft and engines. In 1990, the aircraft was brought out of storage for a final restoration. A dedicated crew undertook the meticulous task of returning the Dash 80 to flying condition, checking and rechecking every rivet and overhauling the old Pratt & Whitney turbojet engines. After the extensive refurbishment, the Dash 80 was prepared for its final flight back to Seattle, the city where its groundbreaking journey began. The Dash 80's final flight to Seattle was a significant event. Piloted by Paul Bennett and co-pilot Jerry White, the aircraft made a stop at Moses Lake, Washington, to pick up a group of distinguished guests and longtime admirers. The restoration of the Dash 80 had been a major effort, involving 15 technicians and engineers working a total of 1,000 man-hours. Among the notable passengers was Tex Johnson, the senior test pilot who'd first flown the Dash 80 over 35 years earlier. The Dash 80's preservation is indeed a fitting tribute to its historical significance. By using dry ice for paint stripping, Boeing not only ensured that the aircraft's restoration was environmentally friendly, but also highlighted the ongoing innovation in aviation technology and practices. Restoring the Dash 80 to its original livery and showcasing it in the Boeing Museum of Flight honours its pivotal role in the evolution of commercial aviation. It serves as a living testament to the advancements and milestones achieved in the industry thanks to the -80's pioneering efforts. The -80's legacy is a powerful reminder of the impact that a single aircraft can have on an entire industry. Its journey from a groundbreaking prototype to a symbol of aviation's golden age illustrates how innovation can set the stage for a monumental change. Boeing's transformation from a minor player to a dominant force in civil aviation is a direct result of the -80's pioneering role. The aircraft's recognition as one of the Smithsonian's most important aircraft highlights its enduring significance in the history of flight. The Boeing 707 indeed transformed the aviation industry, turning air travel into a feasible option for millions of people and shrinking the world in unprecedented ways. Its role in both civil and military aviation is a testament to its design's versatility and impact. Its robust design ensures that it will remain a fixture in the skies, a lasting symbol of the jet age and the innovative spirit of the 1950s.